So this is kind of part 2 of a review for the complex test. I want to go back to where do you even find these things? The first time you ever hit a complex number was when the teacher asked you to factor something, but you didn't know how to do it. Now, the teacher probably at that point didn't introduce you to complex numbers. They probably just said something like, oh, you can't factor that one. But now you can. We could say factor this over the complex numbers. And my little rule has been, and it still works, if you can factor it, you should. But if you can't factor it, then you don't say something snappy like give up or quit. You say, if you can factor it, you should. If you can't factor it, the quadratic formula. So when you're doing your quadratic formula, you'll be bumbling along with x equals negative b plus or minus square root b squared minus 4 is e all over 2a. And then all of a sudden you realize, wait a minute, I have a negative under the square root. Which again, in the old days, the first time you hit that, your teacher would just say, oh, so that makes it impossible. So, well, it's just impossible if you don't know complex numbers. Would you please simplify this all the way down? And then if the question was factor it, remember, this is what factors look like. If I said the factors were 5 and 7, you'd go like this. Well, the factors, sorry, the roots. If the roots are 5 and 7, that's what you do to get the factors. The factors aren't that because the roots aren't 5 and 7. But you'll know the roots in a minute. Then you can factor it. So use a quadratic formula. And factor this. I'll pause for a second. Let me give that a try. Okay, so since there's no calculators on the test, I'm going to show you how you do it with just your brain. Negative b, which is negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is 10, all over 2a, which is 2. This part, negative 36. Ooh, that worked out nice. 4 minus 40 is negative 36, right? Why is that so nice? Because what's that equal to? 6i. Then you have x equals negative 2 plus or minus 6i all over 2. And if you think that's the answer, you have some explaining to do. Why didn't you factor it? Because if you can factor it, you should. And then you get the 2 out, and then you'll have negative 1 plus or minus 3i all over 2. And then what happens? What cancels? 2's cancel. There's my 2 answers. What? 2 answers? Seems like just one. It's actually 2. You do it once with plus and once with minus. And then, what are the factors? That isn't factors. Those are the roots. These are the answers. So think of it this way. It's x equals this. So it's x equals negative 1 plus 3i, and x equals negative 1 minus 3i. Those are my 2 x equals things. And aren't I supposed to set them equal to 0? So then couldn't I say x minus that? You see what I'm doing? I'm really setting it equal to 0. X minus this. And the way I said it was, look, you're going to put x minus one of the roots and x minus the other root. That's the fast way to do it. I'm just trying to show you, you could set these equal to 0, which would move them over next to the x, and you'd have to go x minus that stuff. All right, the easier way to just say, there's an answer, there's an answer. Now I'm going to put them in up there. Negative 1 plus 3i. And negative 1 minus 3i. There, it's factored. It's a little gross, but it's factored. Okay, a little more into the delving into the deep factoring stuff. Let's take something that does factor. Let's just factor something nice for a second. 3x plus 2. Everybody factor that. Did you get x plus 2 and x plus 1? Okay, awesome. Then, does it have any imaginary roots? No. Can you factor it any further in any way? No. So then you know you're done. What if this had been an x squared plus 1? Then could you factor it further if you used imaginaries? Yes, you could. Let's see if you remember how to do that. This complex chapter is kind of complex. I deserve that, Dirty. Look, I'm aware of that. This is called factoring over the complex numbers, and here's the special part, the special sauce. You have to always use a plus and a minus. And if I just put 1, why wouldn't it work? Some kids still think like that's the answer to everything, as you just do x plus 1, x minus 1. Those are conjugates, which seems like, you know, a good thing, and it just doesn't work. If you actually multiply this out, it doesn't come out to positive 1 like it's supposed to. We'd need an extra negative. How could you get that? Putting in an I. If you put in an I here and here, then you'd end up with an I squared, which would turn into a -1, and that would give you the extra negative that you needed. How many of you factored that properly? Okay, awesome. Now look at that. Do you get that that means if I had given you the hint, hey, by the way, I is a root. Do you get, as soon as I said I is a root, you'd have known, well then, wait a minute, I as a root means actually this factor. X minus I would be a factor. And then do you also get that since imaginaries always come in packages of 2, you would have known that x plus I had to also be a factor. So just one clue of telling you I was a root would have told you all that. If I is a root, that x minus I is a factor, and then if x minus I is a factor, x plus I has to also be a factor, and boom, you got almost all of it factored. All right, so then imagine for a moment we gave you that and said, hey, I'm going to actually, we wouldn't give you this, we'd give you this. I'm going to multiply this out. X to the third, that's this times this, and this times this is plus an x. This times this is plus a 2x squared, and this times this is plus a 2. And I'm just going to rearrange it how we'd probably say it. X to the third plus 2x squared plus x plus 2. And what did we just say a second ago? It has a root of I. If that has a root of I, factor it. There is 3 ways to do it. One way, and the way that most people should use, is long division. I know some of you are like, I don't want to use that. Then look at the other ways that I do, but I strongly recommend you know how to long divide. I did go over this again in this unit. You did learn it last year, so it's fair game that we could give you a problem, but the primary way to solve it would be to long divide. So let's make sure you can do it. So how am I supposed to put an I out here if I is a root? Well, you aren't supposed to put an I out there. If you're going to long divide, you should have a factor out there, not a root. So it's the factor that would go with that. Not x plus I, x minus I. Okay, and then that also might seem kind of weird because it's got an I in it. And how are these things going to like cancel out so that we'd have that I is not going to work so well? So then you have to go to the next level, which is if there's an x minus I in it, there's also an x plus I in it. I know it seems like a lot of work. Well, you're supposed to be this smart. You're supposed to know all those things that I just said. So then if x plus I is also a root and x minus I is a root, how could I multiply this all out so there isn't any i's anymore? You just multiply it out. And when you get an I squared, it'll go poof, -1. I think it'd be good at this point, instead of just watching me, for you to go through this now and see if you can turn this into something like this. This is not right, but something like that. And see if you remember that it kind of, again, I'll not do it on purpose right, but kind of like this. This goes here, and then you go like this. That kind of thing. Again, I'm not perfect here, but I'm trying to remind you this is kind of how it looks. See if you can do something like that. I'm telling you, that's not exactly right. And I'm not doing this even exactly right, because it should move over. But anyway, I'll pause for a second while you see if you can do it. All right, so I'm hoping that you knew how to set this up. Let's see if you did. I'm hoping you knew that this one was x squared, outside, inside, less, and the stuff cancels, and then you end up with minus I squared, which is x squared plus 1. How many of you were able to get that far, at least? Okay, good. Then, if we're going to take x here, x times x squared is x to the third, x times 1 is x, and then it gets weird again. How are you going to handle that? That x is not in the right spot. Do you get what I'm talking about? That x isn't lining up right, so I'm going to put it there. And then when I subtract, this will be 2x squared plus 2, because these guys canceled out, and the other stuff came down. And then what must go here? Well, a 2 seems like logical. To get 2 times x squared is 2x squared, and the 2 times the 1 is 2, and I draw the line. And now I have, oh, nothing left. Sweet. Remainder of 0 means I did it right. I have factored it, and the kid gets it marked wrong. Yeah, you factored it over the real numbers. If you didn't already do this, factor it the rest of the way. Factor it over the complex numbers. This is about as complex as we could make it. Mm-hmm. Just a little louder. I'm going to pause for a second. Okay. So, I hope you were able to take the last step, saying x plus I, x minus I. And if you want to say 1i, it's the same thing. And then this x plus 2 is still there. So then I really wish I could squeeze it in right here. So I will. X plus 2. There's your answer. And that's factored across the complex numbers. Okay. I think you could do that. I hope you could do that. All right. So I did say before that there was more than one way to do this. Let me go back in time here and act like I was going to try to do this, but a different way. Now, I'm not going to promise you that this way would work for sure, because it depends. Sometimes these do, and sometimes these don't. But some people know this way of factoring. X squared comes out, x plus 2. 1 comes out, x plus 2. Do you remember this deal where these two then can factor out to the front? And if you don't know this way of factoring, don't try to learn it now. I would just do long division. But if you know that way of factoring, do you get I just factored it? Okay, and then do you get that I am not done yet, and that's why I don't have I yet? If I kept going, look, I factored it, and I didn't need long division. Okay, that's a good way. Then just for fun, if the question had said I is a root, then do you get, if I is a root, then x minus I has to be the factor, and then x plus I has to be the other factor. And then if I multiply that out, that's x squared plus ix minus ix. Those cancel, minus I squared. Final answer, x squared plus 1. If I said x squared plus 1 is a factor, would some of you have been able to just go, well then, I just got to factor this? Would some of you have been able to do it this way? You would have? So what would you have done? How would you, like, I got it set up. What would you do next? I agree. So you're saying this and this have to make that, and therefore that has to be a plus 2. Sweet. See, look, you factored it a different way. There's 3 ways you could have done this. Log division is the most common way, but if you know this stuff well, then there's a lot of ways you can do it. Okay, then let's go back to polar complex. If I give you a spot like here and say that is a 30-degree angle right there. I know that's not the main angle you should be looking at, but it's important. It's called the reference angle. And let's say this is 5. Would you be able to write that in both cis form and polar, no, rectangular complex? Write it with a cis and write it with rectangular coordinates. It's technically a dot. The dot, I'll make it red. It's right here. And it would be on a circle, the radius of 5. The cis is pretty easy. 5 cis, and I can't say 30 though. And I can't even say pi over 6. Raise your hand if you had 5 pi over 6. Raise your hand if you had that one right. Okay, awesome. It's almost everybody. Then you have 2 choices on how to get your rectangular. You can get your rectangular from the picture. I like that way. It's my favorite way. But I want to warn you, and I said it before, and I'll say it again. You have to know how to multiply out cis form. So why don't you try doing it that way this time? I know you can figure out this x and this y by doing that proportion thing with the 30, 60, 90 triangle. And I did tell you, either way, you'd have to go back to the 30, 60, 90 triangle. So I'll draw one here. The same orientation as the other one. And if this is 30 and this is 60, this will be a 1, 2, root 3 triangle. Except just to be careful, I'm going to make that negative because, you know, this is going this direction. So now, here's my question. Do you know how to do this part with cis? Cosine plus I sine. Try it. If you can't do it, then you really got to pay attention in a second. I'll pause while you give it a try. Cosine, I guess I'll get you started. Cosine of 5 pi over 6. But by the way, you could use this, but you don't know what the sides are, so you don't use that. Use this. But wait, you say, it's different. They have a 2 versus a 5. It's okay. The ratios will be the same. Know what I mean? I can still use this to find the angle because the ratios will be the same in this one. This triangle isn't meant to be every triangle ever. It's meant to be the simplest one, and its ratios would work. So if you want to find your 5 pi over 6 using this angle, great. Do it that way. If you want to do it this way, you're going to have to find the sides. And I'm just telling you, it's easier to use this one. Plus I sine of 5 pi over 6. Multiply it all out. See if you can get your answer that way. Be careful with the negatives. And when you're done, you should say something like this. 2 root 3, maybe it's like 2 minus 2 root 3i. That kind of answer. I'm going to pause for a second. And this is not the right answer. I'm trying to say it'll look kind of like that. Give that a shot. Okay, so I'm going to go 2 times, and then what's this part? Well, it's cosine. Cosine's adjacent over hypotenuse. Root 3 negative, don't forget the negative, over 2, plus I sine, and the sine part is, sine is opposite over hypotenuse. Is it happening again? It is! It's the 37th time we've done sine of 1/2. I warned you. That's going to come up about 37 times this year. All right. Sine of 5 pi over 6. You know this. Anyway.
How do you know it's the 37th time? You're making it up.
I am not. I keep track. Oh, dang it. You were paying attention?
That's the trouble with making stuff up. You don't know where you left off.
All right,
Sine
fine.
5, 5, or 6?
You caught me. I'm giving up all math now.
Sine 5, 5, or 6 is somewhere between -1 and +1.
Go torture somebody else. It's negative square root of 3 plus I, and then I'm multiplying that out. There. Ooh, that's it. I think I got it. Raise your hand if you got the same thing as I did. Uh-oh. Dang it. He distracted me. I'm blaming him. All right, then what's wrong? Ah, there it is. I don't even know where I came up with the 2. Okay, sorry. Where did that 2 come from? I know, it's because last hour when I did this, I had a 2 here. That's what it is. I had it in my head that it was a 2. Okay, so then multiplying that out, 5, and I have a negative here, root 3 over 2 plus 5 over 2, and then I need an I somewhere. And by the way, I get asked this all the time. Can you put it in front or behind? Yes, I don't care. If it's a square root, I always put it in front. But if it's a regular number, it really doesn't matter. And I wouldn't mark it wrong if you put it at the end. And I think I've done it right now. Raise your hand if you had that answer. Okay, way to be smarter than the teacher. Okay, next. You are challenged with this. Some of you are going to say, I don't like that way. I want to do it the other way. It's fine with me, but I just remember when you see the test that I told you you needed to know how to do that. And you'll be like, oh, I see why we needed to know how to do that. Yes? 2.5 is just fine, yes. All right. So, what else do you have to know? Well, yes, everything we did yesterday. This is the part where I want to give you a little bit of a freedom. Do you want to know, or do you want to practice this, or this? We're going to do more, so this isn't one of those times, I've been in those meetings before where like, don't ask a question, don't ask a question. I'm going to do more practice problems. It's just whether I make them up or you make them up. So, is there any particular topic? I'll give you kind of like a menu. Say at a restaurant, you get to order something, okay? Would you like the filet mignon? No, that's not an option. Would you like the 3/3 roots of blah, blah, blah? Would you like conjugates? Would you like, I've got 1 over 1 plus I, but I can't leave it that way because I'm not allowed to have an I on the bottom of a fraction. Which of those, the first, second, or the third one? Any nominations? 3/3 roots? The 1 over 1 plus I thing? All right, a lot of people asking about that. I'll do that first at least. All right. So let's say you had 1 over 1 plus I. What is that? Is it a complex number? Yes, but it doesn't look like it because it doesn't have a real and an imaginary part. Okay, so what could you do? Well, first of all, you can't leave it with the I in the bottom. Why? Because that I is a square root. Why is it a problem to have a square root on the bottom? Because technically you're dividing by something that never ends. And in this case, you're dividing by something that's imaginary. So they don't want you to leave an I in the denominator. So how do you fix it? With a conjugate. Let's see if you remember what to do. I'm going to pause for a minute. Let me give that one a try. Okay. 1 minus I. 1 minus I. And then I'm going to multiply this out. Because this and this are called what's? Conjugates. And they are special because they do something special. They don't just simply multiply something out with 4 parts. 2 of them cancel, and you know right off the bat it's going to be 1 minus I squared. And since it's minus an I squared, it really means minus a negative 1, which really means plus 1. Do you get what just happened there? And all of a sudden, poof, I don't have an I anymore. Oh, that would be scary. I like my eyes. I don't have an I on the bottom of my fraction anymore. And so, I have 1 minus I on top, and I have a 2 on the bottom. How is that any better, Mr. Server? In 2 ways. It doesn't have any square roots on the bottom, and this can be written as a real part and an imaginary part. Please split it up into its real and imaginary parts. There's just a different way to write it. that will separate it into two distinct parts. You can take the 1 over the 2 and the negative I over the 2, and there you have it. And doesn't that look like a number that we could find polar complex for, or we could say it's in rectangular complex? No, yeah, that's right, rectangular complex. Okay, awesome. So we started with this, which you couldn't have told me where it was, could you? But I bet you could tell me where that was. So, all right. Any of the other topics that I was giving you as choices you'd like to see? Do you feel like we've done enough of those 3/3 root ones that you don't need to see it anymore, or? All right, I'm getting enough people saying I actually would want one, then I'm going to do one. I'll make it a fast one, though. Just remember, you could use the same process if it's 2 second roots, 3 third roots, 4 fourth roots, 5 fifth roots. We'll just do 2 roots, so they could go way faster. Okay? Would you find the 2 square roots of 3 plus 3i? The 2 square roots of 3 plus 3i. It's kind of a compromise. And so at least get you to see it, and it won't hopefully take that long. Pause, we try that one. 2 square roots, yes. Okay, so first off, I like to draw the picture, so I'm going to figure out where this thing is. Over 3, up 3. And that would be like that spot right there. Well, that's 3, that's 3. And then this must be square root of 9, and 9 makes 18. Now, could I simplify that? Yep. Root 9 and root 2. And that means 3 root 2. There we go. 3 root 2 is on that side. Why is that good? Because now I got cis form. And I have 3 root 2 cis. And then what angle is that? I know that one. That's the 45-degree angle, also known as pi over 4. Awesome. Am I done? No, I just started. So now I got to get 2 square roots. Bigfoot. How do I start? How'd you know I was talking to you? Go ahead. Okay, plus 2 pi k, I can do that. So 3 root 2 cis pi over 4 plus 2 pi k. All right. And then it's de mauve, which is all about, very nice, de move of the exponent. I didn't have enough of the exponents. I better put one more up there. Why, John? Everything has to have that hit. And then 3 root 2 to the 1/2 power. Does anybody happen to know the square root of root 3 over 2? It's not super easy. I could try to figure it out further, but you know what? I'm just going to leave it that way. We're not going to give you anything that weird. And if we did, I'd let you leave it that way. If it was something obvious, like the square root of 9, like if this was a 9, totally would expect you to simplify it and make it 3. Otherwise, you'd lose some part credit. But this one is not that simple. So then I'm going to say cis, and then I'm going to say pi over 8. Why? 2 times 4 makes 8. Plus 2 pi k over 2, and I can make that a lot simpler by canceling those 2's off. It's just pi k. That's kind of cool. But I'm going to even change it a little bit. I'm going to make it 8 pi over 8. Does that make it more complicated? Well, maybe a little bit, but it gives me a common denominator. So I can tell I'm going to add 8 pi each time over 8. 8 pi over 8 is like adding pi. That does tell me something, though. If I'm adding pi every time, it's going to go over pi really quickly, isn't it? So in case you forgot, when I put in k equals 0, it's all fine because that doesn't even exist, because I put in a k equals 0 and it goes poof. 3 root 2 to the 1/2 cis pi over 8. Done. And the next one, k equals 1. 3 root 2. I should put this in a parenthesis because it's not just the root 2 that's the square root. It's everything that's square rooted there. Cis pi over 8 plus 8 pi over 8 makes 9 pi over 8. And I can totally see somebody leaving it that way and all that work and practice, and you screw up, you lose half the credit for it. Because why? It goes over pi. And this 9 pi over 8, if you made a picture of it, would look like that. It's just a little bit past pi. And so therefore it's, well, I like to think of this as 18 pi over 8. And I'm at 9 pi over 8. Thank you, 16. Couldn't read it. I definitely said it wrong, though. That's 16 pi over 8. There, now you can read it. How far is it from 9 to 16? 7 pi over 8. But it's in the negative direction because it has to go this way. So, negative 7 pi over 8 is the angle that'll be here. Who had it perfectly right? Awesome. Does that make sense to you? Okay, good. All right. So, last chance. Any other things you want to know? Then we are starting your lab grading now. What's your homework for tonight? 4 problems of your choice. I would recommend going back and doing ones that you hadn't done before, like ones I had you skip. Option B, you can do problems over again. It is cheating, don't cheat, to go back and take a picture of a problem that you already did in the past. Yeah, it'd be really hard for me to catch you. And yeah, you're not going to do as well on the test as the kid who actually does 4 problems. So find 4 problems. If you want, you can do problems over again. That's legal. Wipe the sheet down. Try a problem that you've already done. But if it's been a while, you won't remember how to do it. You won't remember you even did it if it was 7 days ago. So I'll go back and do 4 problems. You're going to be asked to Dropbox them tomorrow to show me what you did to practice. If you don't do any practice, you'll have to Dropbox a blank sheet with a sad smiley face on it. All right, you ready? A sad smiley face. Good point. Yeah, that would be a frowny face. Okay, so right now, I'm done with the video for today. I hope you, if you need more review, go back and look at yesterday's. That had even more problems of review for this test on complex.